Oh, ready to go. Let's kick it up here. Let's not wait. Second period. Still dealing with triangles. Dealing with triangles. I want to review an old triangle theorem with you that leads into today's new one. Everyone remember last unit, we talked about an exterior angle of a triangle, how I could find that. That was equal to the two remotes added up. You remember that one? So the old theorem would say, first name an exterior angle in my diagram for me. ACD. Angle ACD could be found by adding up which two angles in this diagram? A and B would be equal to angle A plus angle B. All right, everyone remember that one? The exterior angle is equal to the sum of the two remotes. I want to break that down even further today and say the following. Wait a second. Wait. If ACD is equal to A and B added up, shouldn't angle ACD be greater than angle A by itself? Make sense? Because if I'm going to, ACD is equal to A and B together, separate, ACD should be bigger than both of them, without a doubt. Also, ACD should be bigger than angle B. Yep. And this is the new theorem, well, one of the two theorems we'll work with today. Exterior angle is always greater than either remote interior angle. All right, either remote angle. Is that all right? Processing that if ACD is equal to A and B added up, individually ACD's got to be greater than either of them. All right, ready to apply it. I want to hop right into the fire. Can you do it, honors kids? Can we do it? State all the angles in this diagram that are less than 7. Less than angle 7. And just to let you know, I have, let's see, 1, 2, 3, 4. I have 5 of them. Can you find all 5 that are less than angle 7? Well, let me help you out with one of them, and then I'll start calling on people here. Angle 7, inside or outside, my triangles? So it's definitely an exterior angle, right? So it's got to be bigger than remote interior angles inside. I just got to figure out 7 is an exterior angle for what remote interiors. First thing I need somebody to find. Find a triangle. Name a triangle in my diagram where angle 7 is an exterior angle. Let's start right there. Angle 7 is an exterior angle for triangle. Hi, Rick. KML. Good. I'm going to start right there. KML. Yes. I think we can all agree angle 7 is an exterior angle for that one. All right. Name the remote interior angles then. If 7's the exterior, what's the remote interior? We remember our numbers? Actually, we don't really. Actually, yeah, we do, because I'm going to hit a 5, and that's not going to happen. Do you remember old numbers, or do we have to count off again? Should we count off again? Go. Let's go. Get numbers right now. So I don't have to keep repeating, going over and over. Oh, we don't have a 5. We don't have this number. We don't have this number. Somebody start by saying the number 1, and then somebody goes 2, 3.
1, 2, 3, 4, 5, 6, 7,
Whew.
8, 9, 10.
Oh boy.
11.
Everyone have a number. Everybody have a number. 8. Here we go. If 7's the exterior, name a remote interior. 5. Done. So one angle would be angle 5. I think there's another remote interior in there other than 5. Oh, 9. Angle 4. All right. So 5 and 4, both less than 7. Everyone good? All right. I see another triangle, don't I? Where 7 is the exterior. Name it. Name another triangle where 7's the exterior. Now we're rocking. 11.
J and K.
J, this one here?
Yeah, I'm not sure.
Okay, I need it off.
Oh, the big ones would be JLK.
There we go. Perfect. Everyone's good there. And clearly 7's an exterior for that one. Name its remotes then. Now with this triangle. Where are my remotes? 12. Angle 3. Oh, we were ready to rack with that one. Angle 3. And I think you're going to need some letters on this one. 2.
Angle JKL.
JKL. Yeah. Yeah. All good so far. But didn't I say there was 5? Where's the 5th then? I said there was 5. And that's true. You guys found all the remotes. Maybe, Matt. I saw a little quick reflex. Big Matt, you got it or not?
Angle 2.
Ooh. That's correct. He's correct. Y angle 2. Ready? Wasn't angle 7 bigger than JKL? And what two angles make up JKL? Angle 4, which we already knew about, and angle 2. So if angle 7 is already bigger than JKL, isn't it going to be bigger than the 2 that make it up? 2 and 4. Great job, Matt. So those are the 5 right there. Questions? Let's go. Put your groups together, by the way. I should have did this at the beginning. Let's go. Put your groups together and see how many you can get on number 2. Give me all the angles that are greater than 6 now. Greater than 6. And there are 2 answers I'm looking for. 2. Find them. State all the angles greater than 6. There's 2 angles that are greater than 6. Find them. Find them. Let me start help. Is 6 interior or exterior? Interior. So you better find exteriors where 6 would be a remote interior. All right? If you can find an exterior where 6 would be considered a remote interior, that angle's greater than 6. Here you go. Find them. Find them. You should find 2 angles. 2. Dig deep, dig deep. 6 is an interior. Where would be the exterior then? Can you see a triangle where 6 is an angle? Any group want to talk to me here? Anybody have an angle they know is greater than 6 based on our theorem here today? What's up, Rico? Let's go.
1.
Angle 1. I like it. Okay, take a look, everybody. Here's where we're working. Angle 6 is an angle in triangle MKL. Everybody agree? Angle 1 is an exterior angle in that triangle. So 1's bigger than 4 and 6. Everyone see why it's now bigger than 6. There you go. Good work. I said there was 2, though. What other angle up here is bigger than 6? Bigger than 6, other than angle 1. Matt? Angle 8. Look at this now, everybody. 6 is also an angle in the big triangle, JLK, isn't it? Everyone agree? Where 8 is an exterior angle. So 8 then, if it's exterior, has to be bigger than 3 and 6. All good. You cannot cannot confidently say mathematically that an exterior angle is always bigger than the one next to it. I don't know that. That's false. Could be sometimes, but not all the times. The only ones that they're bigger than are the remote interior. Are we all good? Because I'm going to get to an honors level question next. We all good? Okay, let's get to it. In triangle ABD, AB and BC, AB is congruent to BC. All right, so I'll put my markings there. That should also tell me something too right away, but we'll get to that. So which one of the following is true? 1 bigger than 2, 1 bigger than 4, 3 bigger than 4, 4 bigger than 2. Talk it over. And I'm just going to give you a hint on this one. There's a reason why I gave you those two sides congruent. Find something else then that must be congruent and then go from there. Let's go. I'm only give you guys about a minute on this one. If you can't get it, that's fine. But I'm trying to tell you guys, hey, if those sides are equal, something else are equal in that diagram. And then see if you can figure out what angle's bigger than another one. No talking here today, huh? Tough one, huh? All right, guys, what else do you know? What else is true in that diagram? If AB equals BC, what else is true? Got to be something else true. Niara, what else is true?
Angle 1 is congruent to angle BCA.
There you go. Here you go, everyone. Angle 1 and BCA are congruent. Can we all agree there? Angle 1 congruent to angle BCA. We all good there? Okay. Do you see any exterior angles in this diagram? You got 3 triangles in the diagram, right? You got 3. We can all agree there. ABC, CBD, and the big one, ABD. Do you see any exterior angles of any of those 3 triangles? Do any exterior angles exist? Yeah, they do. Grace, name an exterior angle up here.
Angle BCD.
BCD and angle right next to it, BCA. Everyone, yes? So I got BCD right here, and I got BCA. Both are exterior. All right, so ready? Let's go. BCD is greater than, give me an angle BCD is greater than. Angle 2. And it's also greater than what? 1. All right, that's a true fact, without a doubt, right? Unfortunately, though, right, I don't have any of those as choices, right? But that's true. And then the other exterior angle is BCA, correct? Okay. Angle BCA is bigger than what? BCA, bigger than 3. Everyone agree? And it's also bigger than angle 4. No choices though, right? Because I don't have BCA in any of my choices. But because the sides were congruent, aren't angle 1 and BCA the same? So wherever I see BCA, it's going to be the same as plugging in angle 1 because they're the same. Substitution. So not only is BCA bigger than 3, so is angle 1. 1's bigger than 3. Nope. What else? 1's bigger than? Oh. Everyone see how that worked? The angles are equal. And I know because BCA is an exterior, it's bigger than 3, and it's bigger than 4. So if BCA are bigger than both, so is angle 1, because they're equal. Tough one. Tough one. Anything you want to ask? That's just our theorem 1 of 2 right now. Exterior is bigger than either remote interior. Anything? You ready for the second theorem? You and your group are going to come up with the second theorem right now. I don't want to give it to you. Can you guys do me a favor? Find the missing angle of both those triangles right now. Find the missing angle. Find the missing angle of both triangles for me. And I don't even know. Some of you may even know this theorem. I don't know. Missing angle of the first triangle, what do you got? 42 degrees, yep. And missing angle of the second triangle, 35 degrees. All right, this may take a while, but I refuse to give you this theorem. Look at the angles and the sides of both triangles. The angles and the sides. See if you can find a pattern or a relationship between the angles and the sides. Okay, I'll give you as much time as we need here. Discuss it with each other, please. There's a certain pattern between the sides and the angles. What is it? Can you see All right, what do you got? What do you think this big theorem's all about? In any triangle, what happens? What do you got for me? In a triangle, what's so great about the sides and the angles? Go ahead, Maddie.
The two biggest sides form the smallest angle.
That is true. That is true. I'm going to reword that a little bit. In any triangle, where's the biggest side located? That's only in a right triangle I can use hypotenuse. Look at ready?
In between the two smaller angles.
Okay. That's a mouthful. I want to make it shorter. Where's 7 across from in the first triangle? 82. What do you know about 82 degrees in that triangle? Oh, it's the largest angle? Go to the second triangle. What's the largest side? 25. Where's it across from? The largest angle, correct? So in a triangle, largest side is across from and all you guys were correct about it's in between. Yes, that is true. Largest side is across from largest angle. And smallest side, smallest angle is also true. Okay? And that's always true, guys. Always. The largest side is always opposite the largest angle. And same for smallest. All right? All right, so let's try some basic ones before we get to some tougher ones. And then we'll finish up class. All right, can you list the sides from shortest to longest here for me? List the sides from shortest to longest. Well, there's a problem. What is it? I can't do that yet. Unless, oh, good job, yep. Unless I know the second angle, the third missing angle, which is angle B.
92.
Okay, thank you, 92. All right, someone ready? We're going from shortest to longest here. Shortest to longest. Here we go, 9, shortest one up there. B. That's an angle. Okay, B. Okay, hold on. I'll keep with that. BAC is the smallest angle. So what's across from it? What's across from angle A? BC, which is the smallest side. Everyone good? Next one would be. Let's keep grinding. 9. Next side. Anybody have 9? Or we just skipped 9 when we counted? How do we do this?
I think that was me.
Hi.
Hi.
Next one.
Um,
BC, next biggest one.
47. BC.
Okay, that's the angle I'm looking for the side. The side BA. Everyone's good. That would make the largest side AC across from 92. Are we all right, or are we going too fast? Biggest side across from biggest angle. All right, go ahead. Find angles S and T before I ask anybody. We should have found, let's see, what was our missing angles? 73 and angle T 32. All right, what's the shortest side in that triangle? Shortest side in the triangle, 12, shortest side. SR, it's across from 32. Next one, next biggest here, 9. I got SR is the smallest. Which one's the next one in ranking them? ST, which is across from 73. Biggest side's across from 75, which is RT. All set? Okay, you guys are on your own for the next one. Try the next one out on your own. A little algebra to do with this. Little algebra. You can't determine it just based on 3x, 4x minus 19, and 3x minus 1. You got to find out what those angles actually are in degrees. Okay, let's get kick started here. You guys keep working. I'm just going to ask you questions while you're working. What do I know about angle A, B, and C? So I can set up some type of equation. A, B, and C. 11. What do I know about A, B, and C? 3 angles in a triangle. What do you got for me?
They all equal 180.
There you go. 3x, 4x minus 19, and 3x minus 1 have to add up to equal 180. 180 degrees in every triangle. That should find you x. That should get you guys to x. Finding A, B, and C. Let's check our work here. A, 60 degrees. B, 61 degrees. And C, 59. Looking good. Okay, is this triangle isosceles? No, because if it was, we'd have 2 congruent angles, right? Is this triangle obtuse? No, one of the angles is not bigger than 90. It's acute triangle, not obtuse. All right, so now we go longest side now. Where's the longest side going to be? Well, it's going to be across from what angle? B, because that is the biggest side. So what side is the biggest angle? What side's across from angle B? AC. There we go. Because it's across from the biggest angle. Any questions? Because these next two are kind of big dog here. Anything? All right, now I've put some triangles together. And now I want to know, in the entire diagram, we do longest on here, huh? I'm going to change it. Can you guys change it to smallest for me? I don't want to, longest is too easy. I want to go smallest, sorry. Change this direction's the smallest. Which segment is the smallest? All right, before we even start talking, probably a good idea to do what in the diagram? Can you find the missing two angles there for me? Because I can't really start talking smallest about anything unless I know what the angle measurements are. So what are we finding? 60 and 57? Everyone all right? 60 for angle ADB and 57 for DBC. All right, everyone all right? Well, we're all on the same page before I start talking. All right, which one's the smallest? Now, based on what we've done today, I wouldn't blame you. You'd say, hey, smallest side across from smallest angle. What's the smallest angle I'm seeing here? 53, right? So I see 53, you look across, and your answer is probably going to be BD, right? Why not? Well, I got a problem with that. Look at this, look at triangle ABD. Isn't BD the biggest side there? Would everyone agree with that? In triangle ABD, BD would be the biggest side, which means there's two more that are smaller than that. So how can BD be the smallest one overall? If we've already determined that there's actually two more smaller than it. Does everyone see my thinking before we answer the problem? There's no way BD can be the biggest side overall if it's not even the smallest side overall, if it's not even the smallest side in this triangle. All right, so how would I approach a problem like this? Take each triangle by itself and let's rank the sides. So let's start with triangle ABD. Here you go. Rank the sides for me in smallest to largest. Rank the sides. You'd start with what? What's the smallest side in ABD? AD, followed by BA, and then the largest side in that triangle would be BD. Now let's compare it to the other triangle, triangle BCD. Let's rank those right now. Go ahead, somebody. Smallest side in BCD. BD. Followed by DC. Yep. And then I have BC. All right. So determining the smallest side overall, it's really a battle between two sides, isn't it? AD and BD, the two smaller sides in, I don't even have to talk about the rest of them. It's got to be one or the other, because those are the two smallest sides in either triangle. Isn't there a problem with one of them, though, being the smallest side? With what we just talked about. What's the problem with BD being the smallest side?
Also the largest side.
Look, didn't you just rank two that are smaller than it? Does that make, there's no way it could be BD because you just said BA and AD are smaller than that. So is everyone all right? Why I'm crossing out BD cannot be acceptable here. You already wrote there's two smaller than BD. So what's got to be my smallest side overall? All right, AD. Questions there? We got one more that I think I'm going to have you do on your own. Yep, go ahead. Determine which segment is the shortest here, and then I got a bonus question. So which segment is the shortest in this diagram? Ready to talk? Well, I ranked them already, and I noticed the two shortest sides in both triangles are YA and VA. But there's definitely something wrong with one of them. There's no way one of them could be the shortest side overall. Why? Well, for which one am I talking about? Which one cannot be the shortest side overall? YA. Why? It was the largest side in the other triangle, wasn't it? So I'm getting rid of YA. So what's my shortest side? It's VA. And ready, honors kids, for your challenge question? You could think you can rank all of them for me? Shortest to largest now. You think you could rank all of them now? Shortest to largest. What do you think? Could we do it? Shortest to largest. We already know VA, winner, shortest. VA's out. What's got to be next? Keep looking at your rankings. Is YA the next one because it's the shorter side here? Is YA the next one? No, because it's still the longest here. What side is also still shorter than YA? That's got to be next. It's shorter. Oh, now which one can we rank in? Now I can rank in YA. And what about now? What's the next shortest side? Out of the two that are left, which one's shorter? You ranked them. YN. And the biggest side in this bad boy? NA, or AN, however you wrote it. So that's what I would also expect out of you too. Just don't find the shorter side, but also be able to rank them shortest to largest. All good? Okay. So I don't think the assignment tonight should be too bad at all. You guys know where the answer key is. And just another reminder, Monday is the unit test now. Monday, not Friday. Good work today. Good work. Welcome back. If you want to come in during one of my free periods, just give me a heads up, and I'll be after school all this week, including Friday.